Hi guys, today we are looking at extreme values, linear approximation and curve sketching in that unit for unit 5. Today's the second day of extreme values. So yesterday we talked about maximums and minimums and relative or local maximums and minimums. Today we're going to discuss absolute, which means the highest of the high or the lowest of the low. So the first thing I have for you is the extreme value theorem. If a function f is continuous on a finite closed interval from a to b, then f has both an absolute maximum and an absolute minimum on that interval from a to b. So how do you find that? The procedure for finding the absolute extrema of a continuous function f on a finite closed interval from a to b, this sounds really wordy, but it's not that bad, is find the critical points like we did yesterday, evaluate f at all of the critical points and the endpoints of a and b. The largest of those values is the absolute max, and the lowest is the absolute minimum. So let's jump right in. This is example 6, just left over from yesterday. Find the extreme values of that function on the interval from 0 to 6. So step 1 is to find the critical points. So yesterday we learned that the critical points are when we find the derivative and set it equal to 0. So f prime of x is going to be 6x squared minus 30x plus 24. And then for critical points, we need to set that equal to 0. So 0 is equal to 6x squared minus 30x plus 24. Now we need to solve for x. This is a quadratic function, and back in Algebra 2 and pre-calculus, we would factor a problem like this. So when I look at all three terms, I see that my greatest common factor is a 6. So I'm going to factor out a 6, x squared minus 5x plus 4, and then we have to factor that remaining trinomial. So I have an x minus 1 and an x minus 4. So my two critical points are x equals 1 and x equals 4. So one of those could be a maximum, one of those could be a minimum. We don't know yet. So for the extreme value theorem, what we need to do next is find the y values. So what we're going to do, I looked ahead on Delta Math and they organized their work in a table, is we need to test the endpoints. So we need to test 0. Make an XY table here. We need to test the first critical point, which is 1, the second critical point, which is 4, and the other endpoint, the right endpoint, which is 6. So these two are critical points in the middle. This is an end, and this is an end. Back in Algebra 1, when you had a list of x values, you'd come up with your y values. So where do we get the y values? Well, we don't really call them y in calculus anymore. We go with function notation and call it f of x. So what you need to do is take each of those values, the 0, the 1, the 4, and the 6, and place them into the original function. Not the derivative, but the original. So I am going to use my calculator. I'm going to cheat a little bit here. I'm going to go into my y equals and type that in. So I type that into my y1. Okay. And then I do second function table. I'm going to save myself some work. So now I'm into my table, but I'm going to change my table set. I want this whole thing to start at 0 and count by ones instead of 0.5, which is what we have here. So when I look at my table, when x equals 0, y equals 0, when x equals 1, y equals 23, when x equals 4, y equals 32, and when x equals 6, y equals 108. So check those out. Can you see them? Okay. Now, you can absolutely type each one of those individually into your calculator, into your regular screen. This one? That's fine. That will work. No problem at all. Put that 0, 1, 4, and 6 in place of the x's up here in your original function, and you will wind up with those values. Now, the whole point of that is to figure out which one's the largest and which one's the smallest. So whichever one is highest is your absolute max, whichever one is lowest is your absolute min. So we have a 0, Now, there's a couple different ways to write this, and I just want you to be familiar with them. You could write it as an ordered pair, which is 0, 0. That's the lowest, so it's the absolute minimum. I'm going to abbreviate because we're out of space. The other way you can write that, and probably better than an ordered pair, is function notation, where you would say f of 0 is equal to 0. Now, the minimum value is the 0 on the end. That's your y value. The x coordinate, where the absolute minimum occurs, is at x. So you have to be careful of that notation. I'm not so worried about that in this course, but your next calculus course is going to be a little bit more particular about that. And then you want to find your highest value. That's this one, your 108. So 6, 108 is your absolute maximum. It's the highest. But again, an ordered pair is good algebra notation. It's not very good. Oops, sorry about that. It's not very good calculus notation. So an ordered pair is probably better. F of 6 equals 108. This is your absolute maximum. So the maximum value is 108. The x coordinate where that occurs is 6. So a lot of plug and chug for these problems. I hate that expression, but it's what we're doing. So let's try again. Example 7, find the absolute maximum and minimum values of the function given on the interval from 1 to 5 and determine where these values occur. So we're looking for the absolute maximum, the highest of the high, the absolute minimum, the lowest of the low. That can happen at one of the critical points, or it can happen at one of the endpoints. So again, the first thing you have to do is calculate your critical points. I'm trying with this handwriting thing here. So f prime of x is 6x squared minus 30x plus 36. We have our derivative. Now to get the critical points, we set that equal to 0. And I'm going to factor out a 6 in the same step, save myself a little bit of work. And then we factor the trinomial that's left. So x, let's see here, plus 6. Nope, 6 and 1 isn't going to work. Oh, it tricks me sometimes. How about 2 and 3? X minus 2, x minus 3. It's just like teaching at the board. Sometimes I get tricked by the algebra. So when I multiply, I get a positive 6. When I add, I get a negative 5. So my solutions for x are 2 and 3. Those are your critical points. Now, again, we have to test the y values of the endpoints and the critical points. So we'll make a table. When you go to look at some of the Delta Math problems or solutions, they have a longer table. So 1 is an endpoint, 5 is an endpoint, 2 and 3 are your critical points. So do you have to try all the values, 1, 2, 3, 4, and 5? No, you don't. I've had students do that on tests before. You're just wasting your time. You only want the critical points and you only want the endpoints. Again, you want to type those into your calculator. You would put 1 in place of x. What column am I using here? In place of these x's up here. I'm going to do that table trick again just to save myself a little bit of typing. So I've got 2x cubed minus 15x squared plus 36x. Now, I'm not sharing my iPad, but I could do that. So that's what it looks like typed in there. And then when I hit table, it does the calculations for me. Saves me some work. I really, really like that. So when x equals 1, y is equal to 23. When x is equal to 2, y is equal to 28. When x is equal to 3, I have 27. When x is equal to 5, I have 55. So the y values don't have to be anything in particular. They don't have to be small. You don't have to have positives and negatives. They could be all over. But when we look at these, my lowest value is 23, my lowest y value, and my greatest y value is 55. So 123 is the absolute minimum. Again, 1 is the x value, 23 is the y value. 55 is your absolute maximum. And when you graph these, you would see the highest point is at 555 and the lowest is at 123 when you're cutting it off from those endpoints. Now, example 8. I kind of like this one because it's a good review of the calculus, but you do not have one like this in your Delta Math assignment. I just like the natural log in there. So find the extreme values of x squared minus 8 natural log of x on the interval from 1 to 4. Extreme values, this is just a grouping word for absolute max and absolute minimum, extreme values. So again, we got to find that derivative. The derivative of x squared is 2x. The derivative of 8 natural log of x is 8 1 over x. We're going to set this equal to 0. You get 2x minus 8 over x. You have a couple of choices here. I'm going to multiply everything through by an x. Some of you might add 8 over x to both sides. That's fine as well. And when you do that, you get 0 is equal to 2x squared minus 8. I would add 8 to the left, so 8 is equal to 2x squared. 4 is equal to x squared, and then x is equal to not just 2, but we're taking the square root ourselves, so it's plus or minus 2. But we're only looking on the interval from 1 to 4. So x does equal -2, x also equals +2, but the only one that's on that given interval is the +2. So when we go to make our table, here's my endpoint 1, here's my endpoint 4, here's my critical point 2. I don't have to include the -2 because it's not on the interval from 1 to 4. I'm going to go back to my table again. Again, you could type these into your calculator individually. I know some of you are very, very quick at that. I've got x squared minus 8 natural log of x. So I have to put it in the wrong spot. X squared minus 8 natural log of x. That's what it looks like in my y equals. I know that's a tiny, tiny screen. If I go over to the table, now we get decimal values on this one. That's okay. When x is equal to 1, y is equal to 1. When x is equal to 2, y is equal to -1.545. And when x is equal to 4, y is equal to 4.909. Okay. Based on these decimal values, and again, they're not as pretty as the other integers we had. My lowest is right here. So f of 2 equals -1.545 is my absolute min. And f of 4 equals 4.909 is my absolute max. There you go, absolute max and min. So it just ties in nicely to what we did yesterday. And tomorrow we're going to talk about increasing and decreasing on these functions. Every single lesson in this unit, I really like this unit, just builds on the one before. So we just add one little new thing each time. But if you're feeling lost, you need to reach out. You need to ask a friend, ask me, whatever it is, we will help you out. Rolle's theorem. I did not give you any Delta Math questions on Rolle's theorem, but it's something that you should see. So I'm going to show you an example, and then we're going to forget about it. Let f be continuous on the closed interval from a to b and differentiable on the open interval from a to b. If f of a equals f of b, then there exists at least one point in the interval c such that f prime of c equals 0. It's a mouthful. So it's my English translation. If you have the same y value for two different x values, then the function has a horizontal tangent line somewhere in between, and that's why they call it c. So it could be a maximum, it could be a minimum, it could be more than one. You could have multiples. So if you have two y values, you have to have a horizontal tangent line somewhere. It's the idea of whatever comes up must go back down. The same would be true in the other direction. If we looked over here, between these two, they have the same y value. Down here, you have a horizontal tangent line. So it could be max or min. Now, is there anything to solve? No, they're kind of like little proofs to verify Rolle's theorem or to show that it's true, to show that it exists. So the first thing that we need to do with example 9 is say, okay, let's check the endpoints. You need to check f of -2, and you need to check f of 2. So what you have to do first is put those values, the -2 and the 2, into the original function. I'm going to do some regular typing here. Make sure you use parentheses. And I get 12. If I do the same thing again with 2, I also get 12. So that's the first thing that we have to verify. The endpoints are the same. And then we're looking for a critical point. We just want to verify that some critical point exists between -2 and 2. So how do we find critical points? The first derivative. So the first derivative is 4x cubed minus 2x squared. No, it's not. How about 2x to the first? And we're going to set this equal to 0. I can factor out a 2x. So here's 2x squared minus 1. Now, in this case, I factored out an x. That means 0 is a solution. Over here, 2x squared minus 1, we set that equal to 0. 2x squared equals 1. X squared equals 1/2. X is equal to the square root of 1/2 plus or minus. Now, I know for certain that 0 is between -2 and 2. Done. We verified Rolle's theorem. But the square root of 1/2, I'm not really sure about that. So I'm going to enter that into my calculator. And I get 0.7. So plus or minus the square root of 1/2, which is plus or minus 0.7. Yes, also on the interval between -2 and 2. So just to verify, Number 10, again, I didn't ask you anything like this on Delta Math, but it's good practice. We want to find the two x-intercepts of the function and confirm that f prime of c equals 0 at some point c between those two intercepts. Now, this one's a little bit different in that I didn't tell you what x values to try. You have to find the two intercepts. I do know it's an x squared function, so it's quadratic. It's a positive x squared, so it's a parabola that opens up. It's something like this. That's my quick sketch. I don't know where these intersect, but that's what we're going to find out. So we are going to say that 0 is equal to x squared minus 5x plus 4. This is the algebraic way to do this. This factors into x minus 1 and x minus 4. X equals 1 and 4. You could also graph it on your calculator to see them. So on my quick sketch, there's a 1, there's a 4. Those are the x values that we're talking about. Confirm that f prime of c equals 0 at some point. So f prime of c, that sounds like we need a first derivative. That would be 2x minus 5. Well, set it equal to 0. 0 equals 2x minus 5. 5 equals 2x. 5 over 2 equals x. X equals, what's 5 divided by 2? 2.5. Is 2.5 between 1 and 4? Yes, we verified it. I don't need you to write out some long, complicated explanation. That's fine, we verified it. I think that's all I have for you. It is indeed. So try those Delta Math assignments for me. I believe I only selected 6 problems today because there's a little bit more work involved. Yesterday's assignment was just look at it real quick. What's the max, what's the min? So today's a little bit more work, but only 6 problems. So give them a try. Email me if you're getting stuck anywhere. So great job.